Thank you for giving me this opportunity to to share some idea about the experience that we have personally or practically I've gained for the last couple of years, and it's likely to be more than 15 plus years in this particular subject or in this domain. So, dear audience, thank you very much for joining to this webinar session, and I won't spare much time. Probably, if you have, but before beginning of my presentation and the session, I would like just to give some idea about how we are going to proceed. Initially, I'll just give an outline of what will be covered in this session, and while delivering the different segments and chapters, while I discuss or while I brief, if you have any questions, please keep it until the session is over, and we'll have a small Q&A session where we'll be discussing about your questions, anything or such. There is a chat box. You can put up your questions, and or if you have anything specific to discuss. So thank you. So now I would like to just go directly to the presentation contents. So this is the presentation or the session content. It is mostly for the cloud adaptation. So we all perhaps know about cloud, but how it is benefited or it is beneficial to the project managers. And there is a known issue for everything, for everybody, and particularly for any project managers or any managers for any enterprise, is considering about cybersecurity or specifically on the cloud security aspect before obtaining any cloud services that any enterprise feel to avail. So, as I likely to be to told in the first place that there are a couple of chapters that I would like to cover through this session, and it's particularly divided into 5 segments. The first segment is the basic principles, the cloud computing kind of definitions, kind of like what we understand or how we see a cloud computing actually. The second chapter goes with the data center. So a cloud runs not particularly on anywhere else. It's not intangible. It is actually resides on certain data centers. So how a typical cloud data center looks like, how it operates, and what are the pros and cons of a data center who are delivering cloud services. I'll be showcasing that part. The third chapter will be something like the most important factor of this entire discussion. It is the cyber fear and the common questions. I mean, these questions definitely comes in our mind, more or less. So how we get, what are the questions? Is the presentation has started? I mean, can you practically not see it?
No, we cannot see the presentation.
No, we cannot see any presentation.
All right, I shared it. Anyway, I'm doing it again. Is it visible now again?
Yes.
Yes.
It's okay now.
All right. So these are the 5 chapters that I was actually going through. So the third content would be the cyber fear and common questions. We've covered the this particular area, and fourth content would be something like, well, we have covered the cyber fear and we have done enough. So how we are going to see it in action. So there will be some use case, particularly one particular use case that I'll be discussing about how we are going to securing our data hosted in the cloud infrastructure. And last, how the globally it is being accepted, like the fear versus reality. I mean, are most of the organizations have moved into cloud, or what is the pattern, or how do we foresee it? So these are the 5 major components that I'd like to be covered. So first come with some sort of definition, but there is particularly no specific definition of cloud computing. There are many definitions, more or less all are correct to some context. But first, let's try to define it. I mean, how we're going to define cloud computing. As per the Wikipedia, it has covered almost everything, which more likely to be we know how cloud works today. It's basically an on-demand availability of entire computing system, like computing, like storage, like memories, like networks, like power, anything and everything, which is actually not being owned or even managed by myself. I'm actually controlling the entire system. The active management is done by the user, but the asset or the resource of entire facility is not my property. So how does this work? It works on a rental basis, as simple like that. So instead of building of an entire setup of IT infrastructure, we just rent all the services or the entire IT infrastructure from a service provider. And basically, when a service provider creates an IT infrastructure facility for many, which is called in short term multi-tenancy, it is actually known as a cloud computing, nothing more or less. But why the name cloud is specifically being used? It was practically used by way back some early 2000 or late 1990 to 2000 transition phase, where internet was, kind of bubbling up and growing up in it was showing a good or great trend to be a bigger domain in the whole world, whole community. So the AWS, it was known as Elastic Cloud Computing. So they started this concept and used clouds because, the term cloud, because cloud cannot be touched. It is something vaguely presents around us. So a subset of things which is not inspected in a very clear context, we typically call it as cloud. So since there was no specific definition and no specific use case or even no specific, tangibility of any service or any equipment or any device, nothing as such. So that's why the term cloud was getting popular day by day. Till 2010, it was not very much popular, but globally, in Northern Europe, in North America, and in Europe, it started adaptation, or it started beginning to grow something like to be a global change in the IT and telecommunication infrastructure. So the cloud is nothing, it is mostly for distributed computing. So earlier, before cloud, we had distributed computing, but it was not an easy availability thing, or in terms of technology, in terms of cost, in terms of investment. So altogether, it was very expensive, but cloud enables the distributed computing quite easily because you don't need to buy out anything, large infrastructure, equipments, even for greater, higher IT skills people. So what is the heart of the cloud? Cloud computing is entirely depending on the virtualization technique. So there are many virtualization. Virtualization has several other names, and technically it is called, or it's known as like hypervisor. Even sometimes it is known as nowadays it's a very common term we use, like container virtualization, or container machines, like Kubernetes, like Dockerization. So these are the new technical jargon that has been come into the very common industry and very common technical people, or particularly who manages the IT resources and all that. But fundamentally, it is built on virtualization technique. And as we all know that virtualization is nothing, it actually helps or enables a physical hardware resources to use in a very efficient manner, so that the idle resources are not kept in idle. So one system or one particular hardware can be used for many purposes, with many operating system, with many services to be installed in a single piece of hardware. So that was the beauty of virtualization. And when virtualization was coupled with like multi-tenancy, like it's not a single user. I'm not using the entire subset of hardware alone. When these hardware are mostly prepared to be used by some external parties, the end users. So there comes a mechanism called the accessibility. So when accessibility to this virtualization was growing up, the cloud concept was actually came up into a complete phase. Like nowadays, today, what we see the cloud installations of systems or services that we are accessing is nothing. It was predominant on the fundamental of the virtualization. But now there is a particular and specific definition given by NIST. It says that cloud computing is a compilation of existing technique and technologies. So you see, there is nothing new technology or technique is actually available on the cloud computing. It's existing technique and technology, and it is packaged with a new infrastructure paradigm. So this infrastructure is kind of a bit different. We don't see it on a very common on any enterprise or any common setup. It typically holds or resides on certain specific providers, service providers, particularly data center providers. So this is something which we don't see around, but we understand that the existing technique and technologies are all being deployed, are all being managed and kept into the cloud infrastructure. Interestingly, it enables a couple of many things, like it has the scalability. Previously or earlier, it was very humongous job. You need to buy a number of hardwares, 1, 2, 3, 4, 5, like piling up of hardwares, putting up, filling up the racks, etc. So scalability means you need to purchase hardware, you need to put it up, you need to prepare it, configure it, and then service it would come up. So it was a very time scaling process. Elasticity, it means the computing and memory and storage, they can be expanded or reduced just at a few clicks. Business agility, it has grown multifolded. There are many businesses nowadays which needs, time-bound effort. For instance, for any banking service, think about on a particular hour of a day, ATM machines or any, let's say, or any automated booth or any POS service needs high amount of, traffic. Traffic means people are accessing those networks at a particular time of a day. So let's assume you have 100 computers and 100 computers are not good enough to cater for that particular hour of day. Maybe you need another 100 computers. So cloud actually gives you that agility to have your static 24 hours, 100 computer with an additional 100 computer on a real time or runtime or an ad hoc basis instantly. Faster startup, the typical hardware takes a long time to boot up and to check and balance everything. So it's a very lengthy process. Cloud computing reduces drastically. The management cost, you don't need to buy anything. You just rent the entire service. As you can understand that renting is always a bit cheaper than having a capital expenditure like buying out new services or a new entire set of equipments. And just-in-time availability of resource, it actually is correlating to the business agility as well. So whenever on-demand based services you need, whatever the size of the machines, the size, the scale of the services, or the amount of resources, computing, memory, or anything as such, you can just scale it up momentarily. So this is the precise definition, which is nowadays is actually correct definition as cloud. So these are the pretty good key point that we all understand that it helps us to adapt cloud. So fundamentally, it has low initial capital investment. So you'll not find any cloud operator nowadays or even last couple of years that they ask for any upfront or anything for like preparation or readiness to be alive. So you don't need any upfront or any capital investment initially. Probably all you need is to book certain amount of virtual resources. That's it. And typically they come, of course, they come in a prepaid basis. So shorter startup time for new service. So you can consider any service to be up and running if you have any ready application of your own or any generic application, whatever the context is, you can start up your services or any new services very, very fast. The lower maintenance and operation cost, it has nothing comparing to your own infrastructure. It is as simple like that. Only cost and operational that involves is the human beings. For instance, the IT resource person is the only required component to run or maintain the entire services. Higher utilization, definitely entire thing or the complete virtualization works on a cloud computing works on a virtualization environment. So you will get enough utilization, even if you have your own dedicated hardware into any of your data center facility, which is typically known as co-location services. But even though if you have co-location services with hardware, you can create your own virtualization schema and build your own private cloud. Easy disaster recovery. It's like very simple. Like in every cloud infrastructure provides machine snapshot feature or entire machine backup feature, or to some extent like other block data where you can store or take backup your particular contents or anything as such. So there are many rich tools, techniques, and services available for disaster management. So in the fundamentally, I just told you that the advantage of cloud computing, we all probably know that. But if you think about how this entire cloud ecosystem was built, so it has certain feature, it has certain attributes, and it has some certain essentials. For instance, the feature is fundamentally only two. I'd say it's basically these subsets, the attribute feature and the characteristics of cloud. It is also outlined by NIST, the National Institute of Science and Technology of US. So they have also outlined the cloud computing background. Like cloud service definitely has to be run on an online service. You cannot run an offline service on a cloud. So if you have any offline service, definitely it won't require any cloud. For rental of IT service, it works like an utility-based services. Like you're buying out any services, virtual services earlier, before cloud was much in existence. We are used to like to buy many virtual product like software buyout or service buyout, solution buyout. And for virtualization and cloud computing came up with a rental-based services. It's much more like to be an utility services. So what are the attributes? You can do it, you can deploy it fast. It has very significantly, almost zero capital investment, but only the service cost is involved. Mostly works on a subscription or on a utilization basis. There are many instances and nowadays in cloud computing where we can hire a computer even for hourly basis. So not for instance, you need certain services which you require maybe for 3 hours or 6 hours a day. So you can hire computing or cloud services even for hourly basis. And definitely multi-tenant. I mean, the service is not designed only to deliver services for a particular enterprise or particular stakeholder. It involves many stakeholder, many party, many tenants can come in and avail the similar services. It is self-service. In the network is completely ubiquitous based. The location, resource pooling, everything, it's completely independent. It doesn't hamper from one user to another. So you are creating all your own resource or service pool. Elasticity means scalability. So you can expand or you can reduce your requirement of services at any moment, and you can actually measure your service. So since you are able to measure your service, which you earlier couldn't do through a legacy network or legacy computing system, now you can actually measure what are the technical requirement or the technical computing resource that you need. Based on that, the rapid elasticity actually works. Perhaps we are familiar with these three terms, which is called the SaaS, PaaS, and IaaS. SaaS is software as a service, PaaS is a platform as a service, and ES is an infrastructure as a service. So cloud actually aims to deliver three types of services, and it is intended who are actually the end user for any SaaS services or PaaS services or ES services. Mostly business users, like any office, they typically depend on services. For example, email services. For example, CRM, ERP, websites, blog, uh, virtual desktop computing, or any CRM, anything and everything. So these are the services that enterprises typically use nowadays. Uh, we have been using cloud compute, cloud services for a long time, like more than like when Google services came up with plenty of services. We all know what Google does. There are many other Google like similar service provider. Microsoft does the same thing. I mean, like free to pro bono services. All is over there. There is a service provider like Zoho. So there are many global operators active in different regions in different countries, and we are quite familiar with different cloud services. So every business user nowadays uses some context of any SaaS services. And earlier we were used to use or to avail free services. Nowadays, since the corporate or the enterprise heavily relies on much more additional features apart from the free services offered by them, they take the commercial or the enterprise services, which is catered and absolutely designed for the enterprises. Now, almost every good organizations use like document services like Google Drive and all that, like any communication platform, like we're having this webinar through Zoom. So even many organizations, many enterprises nowadays are taking this Zoom. Zoom is entirely cloud-based services. There are email services. We take dedicated service from cloud service provider. You can consider Gmail. We're taking Microsoft 360s. We are even taking AWS services from different custom service providers. For platform services, yes, it is something different. Mostly it is needed for the developers and deployers. Like there are many intermediate software service provider who deliver and deploy their services on cloud. For instance, somebody builds an application, a mobile application, and they would like to sell some subscription model. For instance, if you think about an accounting system which sells services to subscription package. So the developer develops the application, put it on the cloud, and takes the other cloud ecosystem services. For instance, cloud providers database, cloud providers storage system for storing public information. So these are many other different services that actually cloud providers offer, and developers and deployers take those services. Those are the value added or the additional component that they need. So platform service is another service avenue. And the fundamental thing is infrastructure services. So their infrastructure means the service provider itself. So it means they're ready with facility like they have a data center, they put up equipments, and they have put their software like cloud provisioning software. We all know some tools like Cloud Stack, like VMware Cloud, like Microsoft Cloud, like Azure Cloud, Microsoft Azure. So these are on-premise. There are many on-premise cloud. There are many off-premise cloud. There are many public cloud. There are many private cloud. So these are all the providers that actually deliver these infrastructure facilities. Like at the end node, at the end result, the end product or end service is nothing but setting up like computing resources, like computing, memories, and storage, along with certain virtual appliance. Like if you need any router, you can get a virtual router. You need a storage system, you get a virtual storage system. So these are different other additional components that infrastructure provider is ready to deliver. So who needs what? So this is the enterprise decision. Like there are a few on-premise, there are a few off-premise or the hosted premise. Will come up like the other discussion or the debating factor, like why we would like to put our systems on a third party where we don't know where is it, or how they are treating our data. So that is a different discussion that I'll be covering up in the next slides. But on this particular thing, particularly if you look on this from the left to right zone, the on-premise is organization control, and the more you go for the infrastructure, platform, and software as a service, it goes or it is shifting down towards the vendor. So it is something like that. Organization controls the vendor, and the vendor selects the cloud services, and the entire IT ecosystem nowadays managed. How it worked earlier, the vendor used to provide services. There are multiple vendors like hardware vendor, software vendor, solution vendor, system integrator vendor. So there are too many vendors earlier. So if you shift more and more on cloud computing, you probably would see that you probably would be requiring less vendor management. Like hardware vendor, you can eliminate it. System integration vendor probably you also can eliminate it, because cloud service provider typically provides a lot of system integration and integrated services altogether. So you can also eliminate that. So all you need to do is you can probably, from a corporate perspective, you need to manage the software vendor and let's assume the managed service vendor. So managed service is something like that. Software vendor typically develops software, and the managed services typically runs the day-to-day operations and services, manages, maintains other key factors that requires from different computing demand or requirement. So that is the IT part that the managed service provider or the vendor typically looks after. Sometimes software vendor also does the managed services work. So there are also sometimes there's a coupled, sometimes they're not coupled. Delivery mode, it's like a pyramid hierarchical. You can see the services. So all the services, there are a few examples like Google Docs, MobileMe, Zoho. These are the endpoint services where different regions are availing or taking various cloud services. We're using Google Doc. We're using like Google Spreadsheets. We're using let's say Microsoft 365 email or Gmail. There are many options out there. We are taking file storage system like Drive. There are Google Drive. So there are many services and tools, techniques, technologies nowadays available from different service providers, manufacturers, vendors, and developers. The mid-tier, these are mostly the platform provider like Microsoft Azure, like AWS, like DigitalOcean, like Linode. So there are many cloud providers, platform providers nowadays available globally, and different operators are active in different regions, like I said. And infrastructure, yes, this is something like infrastructure is evolving, and infrastructure relates to the technique and technologies that we will be adapting in the coming days, like next 5 years, what is going to happen, or how we are using this cloud computing today. Different standards, different newer techniques, different business logic models, etc. So there are a few infrastructure provider who takes the global lead. For instance, Amazon, for instance, Rackspace, for instance, Sun or Oracle, or like Terramark. So these are the different infrastructure provider who actually build or take the leadership in deploying and developing the cloud technologies. So it is entirely evolving. It is evolving day by day, but it doesn't evolve drastically. Like in a very short span of time, it doesn't. The entire technique or the solutions doesn't come up. It takes. It's a very longer process. So if we now divide or split these, the infrastructure platform software lifespan. Typically, an infrastructure platform has a lifespan of 7 to 10 years. Typically, for a platform architecture, it is like 5 to 7 years. Typically, for a software ecosystem, it is a 3 to 5 years. So since software, it is very rapid and very mature. It is maturing every day. Software techniques, software technology, and the access level tools and technique, they evolve very fast. And if you think about like 3 years ago, how a website typically globally looks like, and after 3 years down the line, how it looks like nowadays, it gives a clear distinction to your, clear distinctive difference. So you can understand what I'm talking about. Like for instance, the software, it has a very fast and rapid development, but infrastructure, it takes very long development, since it involves many ecosystem to be upgraded or to be adapted with certain new technique or technologies altogether. Since it is heavily dependent on core R&D and the research and development by global manufacturers. And typical fear factor, I've just outlined 4 key typical fear factor. Number 1, cloud is a black box to us. I mean, we don't know. It is completely invisible. I'm putting my email, I don't know where it is. I don't know where the data, my mail is residing at this moment in my Gmail box. Is it coming from Singapore? Is it coming from Malaysia? Is it coming from US? Is it coming from Russia? Is it coming from where? I have no idea. So it's coming from somewhere else. And it's not like that. The internet technology or the HTML protocol works in such a way that, generating an email interface like what we see on our screen, let's assume there are more likely to be 300 elements. 300 elements could come from 300 different locations. So HTML has that beauty. So it's a decentralized, making piece of puzzles into a single piece. HTML does it beautifully, or in other words, the web application works in that way. So it's an entirely black box. We don't know how it works. We don't see it. The second most fear is we don't have any idea how it is being controlled. Like who is controlling it? I'm putting up, I'm saving certain data, certain amount of information somewhere else, and all of a sudden, one fine morning or any next fine minute, I may fear of losing my data. It may be gone. And not think about it in that way. Then the second point, let's assume the provider is very honest. He's very keen to your service. They have a very international reputation. But now think about, I have given my cloud access to certain key person, like my IT persons, like my IT team, or to some other persons. And yes, it is something different. Like you are putting your trust to certain number of people, to certain resources, and they probably know where you're keeping your data. So that becomes an automatically threat. Like I'm putting my data on the cloud. Okay, cloud provider is absolutely okay. I have full faith on him, but I have no faith, or I have no trust, or there is a high chances of probability of pilferage within my organization staff. So that is something we cannot avoid. And the last but not the least, the typical data confidentiality, integrity, privacy issue. For instance, I'm putting some copyrighted material on the cloud, and I don't know whether my cloud provider will copy this entire content and share it with somebody else. So there is a certain amount of higher threat that I might be in a position to lose my intellectual or any proprietary data, which is putting into my cloud. So these are the typical fear factor. But now if you think, what would happen if all these fear factors were residing into your own premise? Can you answer that? Are you sure that you can eliminate the black box concept? You have to rely on your vendor, like your hardware vendor, like your network vendor, like your software vendor, like your implementing vendor, like a system integrator vendor. So the risk remains the same. However, you have certain direct interaction with these vendors. But whereas you are eliminating most of the vendors, if you move into the cloud, that is the biggest difference. Think about the control. What would happen? You're controlling, you're powering up your own computer, your own servers. your own network devices. So you have your full control. I feel I'm under threat. So I'm just putting my entire data center, I'm just unplugging the data center, I'm unplugging my routers, switches, everything. So am I safe? You feel in that way? You can do the same on the cloud infrastructure as well. Like if you have your own virtual infrastructure appliance and all that, or any co-located facility, you can do the same. Being, treating or managing data with cloud provider, he doesn't have anything to do. So having a trust factor amongst your employee staff or your IT resources or any vendor dependency, the trust factor remains almost the same if you move into the cloud or not. And last but not the least, any digital data, any content, any file, it can be copied, whether it's in the cloud or even if it's in your, under lock and key. So once you put, there are many chances, many occasions where even these lock and key data were stolen or being breached. There are many occasions. So this is a typical fear factor, but we all probably can eliminate, and with the meticulous act, if you take it and precautionary measurement, keeping in mind all these factors. So now I'll be moving into the next chapter, the cloud data center, how typically it looks like. This is a diagram. I'll not go into any details or anything as such. Think about of an IT of any good or quality enterprise. Think about a garments. They have a manufacturing plant. They have an administrative office. They have certain sales office. They have certain probably some other office places or anything as such. So if you think that all ecosystems will have excellent IT infrastructure, you probably will be doing, or you probably won't be considering that way. So you'll be considering like, okay, fine, my factory needs this amount of IT resource, my head office needs less amount of IT resource, my admin office needs, let's say, in between the resource. So you are actually curtailing your original demand. So because all facilities are not completely facilitated, because when you set up a cloud infrastructure, the data center considers and thinks all the aspects. Like there are ISPs will be connecting to the data centers. So there has to be greater routing or optimum routing design in the data center, comparing to any enterprise routers. Think about the other network, like the NICs operators, national internet exchanges. Think about the global internet exchange point. So these are the other key points that you cannot actually avail in any enterprise or any office environment. It is practically, I would say that near to impossible, because it comes with humongous cost, and it doesn't make any impact over the business operations. So this is the different example that a data center can actually build, having considering multiple or many operators putting into a single place. So this is what a data center operator technically designed on a high level wise facility. Now comes with the data center tiering. So there are many data center tiering. Any enterprise can consider that, okay, fine, I have very sensitive data, I have money, I want to build my own server facility, or let's say a data center facility of my own. And think about the other factors, like having your server, having your routers, having your softwares doesn't make complete liberty. So this is a matrix. So there are tier 1 data center, tier 2, tier 3, and tier 4. Nowadays, a cloud service provider, they start with a minimum tier 3 compliance or tier 3 certification. And the best operators obviously goes with the tier 4 certification or tier 4 compliance. So on a tier architecture, it is very simple. Like you have for tier 1 and 2, you may have only one component, like you have one server, maybe you have some spare. for connectivity and delivery path. Maybe you have one ISPs or one connectivity, or hardly you can cater two. Are there a single point of failure? Definitely you have. The first thing is the power itself. You probably are taking power from one single phase, one single power source. Maybe you're having a single generator, maybe a common generator facility, all that. Maybe you have a single UPS, maybe you have a single rack. So these are the different facts that you cannot, it becomes very costly. And finally, the downtime. So any corporate house or any enterprise may consider setting up its own data center, but at a cost of many downtime issues. For example, if you have a single data center with the tier 1 architecture, you probably can have at a maximum of 28. No matter how better or best you have deployed your data center, you can actually have certain amount of downtime, like annually 30 hours, nearly 30 hours. If you go for tier 2 architecture, probably you can expect like 22 hours. But if you look at the other tier 3 and tier 4, the outage facility or the outage amount is significantly very interesting. For annually, you can expect like maximum 1.6 hours of outage, or for tier 4, it is less than 0.4 hours, which means an hour, a quarter of an hour, 15 minutes maximum out of 365 days. So you see, they consider so many things that your services literally or practically typically doesn't go out. Can you remember when Google or Gmail or any even paid services went out, which you have opted for by far? Probably cannot recall. And then the cloud provider typically set up data center based on software orientation nowadays, because it is called the hyper-converged infrastructure. It means there are lesser hardware components other than servers and storage systems and core network component. Other than that, there are many edge devices like edge servers, edge routers, edge storage. There are many endpoints which are typically available as a virtual appliance. You'll find many virtual appliances in all the cloud providers globally. So data center used some sort of pooled resources, like for instance, you want to buy like 100 computing. 100 computing means 100 CPU. You need to buy some sort of let's say 1 terabyte of storage, and you need your buying plan also incorporate something like let's say 10 terabytes of RAM or memory. Out of this entire asset, now you are planning to set up like 5 or 6 different types of servers. For instance, you are putting one access control server. For instance, you are deploying one email server. For instance, you need another, let's say a CRM server. So you're creating 5 or 6 servers by extracting the resources, the bundled resources that you have bought from the cloud provider. For instance, for a CRM, for an email server, you probably need like 200 gigabyte of space, need a certain 8 gigabyte of RAM, and maybe you need 8 core of CPU. So you, from your 100 CPU resource, you're extracting 8 resource. Now you have 92 resource for other services. You are acquiring 8 gigabyte of RAM out of, let's say, 500 gig RAM. So you're extracting only 8 gig out of 500. The remaining memory are allocated for other machines. So through this way, you are having your pool virtual resources efficiently, no matter how the cloud infrastructure provider is designing to deliver its services. From which particular hardware, it is actually the software designed from the cloud provider. Automatic service provisioning, it is the core and heart of the cloud. You don't need, it's a very simple thing. You never call or never email or never have any face-to-face or any sort of discussion prior buying any cloud services. So it is something that you are convinced with the services, you buy out and you start deploying it. You don't need to talk or discuss any service provider like like how you're going to do it or what to be done. So that means the cloud service engine is quite user friendly. So that means many even non-technical people can actually build up or take or using cloud services as it's very user friendly. For security infrastructure, many data center use public infrastructure and they deliver it. If if you have, I mean, if there is any IT person, definitely there are many IT persons over here. So they must know that there are certain private keys are being generated while accessing certain data centers, and you are keeping your private key and data center having the public key allocated. And when this key pair, asymmetric key pair is matched, then you actually have the server access. The unified data center is also a part of the whole process. So altogether, this is a software-oriented data center. So once again, I'm coming back to the customer's trust, level of trust. So providers sometimes also need certain amount of trust from the customers. So it's not only the customer that only needs to be, trust or to be dependent on the cloud provider, whether it's okay for me to avail. On the other hand, the provider also has certain amount of trust. Like cloud provider typically believes or takes the opportunities in their mindset that the customers are trustworthy. So they create an ecosystem which is already controlled with many things. So that means they have a certain amount of trust that customers can't do anything evil. Typically, if anything goes evil, if any customer does anything bad, so they have so many intelligent data pooling, data collection, and monitoring system that they can understand there's something illegal or something not legitimate is going on certain user account, so they can suspend it immediately. So physically, it doesn't matter, but users are continuously using cloud services since you have rented the services at the fullest. Cloud provider typically fear only another cloud provider. So that's the only resource. When it comes on resource sharing, they have the only fear factor, nothing else. So there is another, last but not the least, fear factor that works for the cloud provider is the insider, the cloud, the employee, the IT staff, the management. If they go with an evil action, yes, it's an internal pilferage. Probably you know the auditing process, how we're going to mitigate it. So there are many controls, how you're going to control your internal access, internal resource, trustworthiness. There are many key other factors. However, it can easily be mitigated with a single, it's a physical validation, employee validation. There are many practices around the whole world. So the common questions. Infrastructure, security, network, and hosting appliance. It is the security part. So I have put my infrastructure, I have taken my infrastructure service, the network, host, everything over there. So how I'm going to, it is going to be correct, or why I believe that it is not going to be, the application is going to be hacked, or application proprietary system is not going to be, shared by somebody else. So it's a common question. Data security, like data transit, like since it's a server client model. So if it is in transit, there is a possibility of data being probed, data being captured, data being copied, and there are other possibilities like data in rest. Data in rest meaning I'm storing my data on a certain remote cloud storage system. That means my data is at rest. So anybody, or there is a possibility, can have the access on that resting data. And last but not the least, while you process your data, it is a combination, like it's in transit. It could be inside the data center. It could be like taking backups. It could be like sharing your data to other service providers. So these are the other risk factors. The important thing is another security aspect is the identity and access management, which is called the IAM. So it typically has like the authentication, how you're accessing your cloud infrastructure, how good your application itself is. like the SSO, single sign-on, like the multi-factor, like accessing to the cloud. Maybe you need another factor like an SMS OTP or an email confirmation, or even it's a key pair integration. So there are many multi-factor integration nowadays cloud providers offer. And finally is the privacy, like what kind of data you're putting in the data center, whether it's violating it, violating the country, violating your country, violating your service. So there are many aspects. So privacy is a good concern. There are many multinational companies who don't like to put data on certain countries. There are many government institutes, particularly for the government, they don't want to put their data on anywhere else in public cloud. So there's a many privacy concern. So once again, the question comes in like the confidentiality factor, like the integrity factor, like the availability factor. So these are the cyber threat and the denial of service. There are many factors that you actually can that actually you face every day, even on your on-premise data center. The fear also continues on the privacy issues, like your private data or your client data are somehow got leaked or somehow got manipulated while you are storing it. So there are many other options. There are many key fundamental factors that you fear that your data would be compromised, or it could be tampered, or it could be shared amongst to many persons, which are typically belongs to some IP rights. The forensics, the audibility, like what happens if anything goes wrong? Are there any forensic availability, forensic evidence? Are there enough forensic evidence available? How it worked, how it breached, how data breach happened, how anything goes wrong? Can I get all those information available? Yes, of course. It is even much better than on your on-premise. You don't keep any, typically don't consider having a lot audit and traceable data into your own premise, whereas the cloud provider typically has it much concern, because any client anytime can ask for it, so that they keep it very religiously. And the legal transitive trust issue, it is there are many standards globally out there. Like for health segment, there is a HIPAA standard. For financial segment, there are PCI DSS standard. So all these standards are mostly complied by various data center. So if you're considering to put up any financial infrastructural service on a cloud, you may think about the provider may have whether they may have any PCI DSS compliance. If you're health conscious data, you may think about like the provider may have a HIPAA compliant data center. There are many other compliance certifications like the Uptime Institutes, like TIA. So there are many other compliance. So you can consider that if the data center or the cloud provider has already these certifications of compliance available in the center, you can have certain amount of faith and trust that there are many controls have already been covered. Cyber threat model. There are 4 key elements like the attacker, the rank of the threat, and the mitigation strategies. And finally, the solutions if there is any cyber threat occurs. Typically, many cyber threat attacks, or most of the cyber threat attacks that we face on-premise setup are being, very interestingly and very collectively, like having, collaborative cloud service provider, for instance, Azure, and then Cisco, and then VMware. There are many other global players who exchange many interesting and very important malicious attack amongst them, and they prepare beforehand, upgrading their data center or the cloud infrastructure on a very regular basis, which you typically cannot do or afford on your on-premise setup. So at a quick go through, you probably can understand like the client, the cloud provider, and everything. You have the malicious insider attack. So there are many key concerns. If you have already compliant data center, probably these are already covered. Like who are using it, how can I encrypt it, how the data has been accessed, who are accessing it, the machine control, who is actually having the machine control, the password algorithm, the authentication mechanism, everything. These are very beautifully addressed almost all the cloud providers. For the outsider attack, yes, like DOS attack, probe attack, malicious traffic, network traffic. There are many things, and you simply have to pinpoint on the intrusion on the network level and the man in the middle. So these are very high level attack that we typically and don't see in now on everyday basis, but it happens. It happens, and it happens on a very targeted manner. So if you go for cloud, can you identify or can you answer where the target is located? Of course, yes, you can. On-prem, probably it cannot. There are many limitations. If there is any co-located or in the same premise, is it coming from the attack coming is originating from the similar or the same facility or the other in your inside malfunctions, malicious code which is doing the all the attack? You probably can find out, because cloud provider typically has very detailed probe engines, and then the monitoring, and then predictive data analysis mechanism, which you don't have, or we don't have. A generic user don't have those tools and mechanism in place. And finally, how we are getting or gathering those information. If there is any typical service needed, probably cloud service provider would come up and give you all this information and help you in improving your security and the software systems. For the manager perspective, the cloud actually has a 5 life cycle. Like it has 7 life cycle phases. Like the generation, when you generate the data, when you use the data, when you transport the data, when you transform the data, when you store the data, when you archive the data, and when you do the destruction of your data. So it's a life cycle. So from generation to destruction, all has to be covered. You may fear that even if I destroy or destruct any data, is it really being destroyed? If you take a free pro bono services like a Facebook content, it probably cannot have any answer. But if you take any services from an AWS or from Azure, if you go through their agreement, terms and conditions, they allow you to shred your data. That means even they don't have or keep any image or any backup or any secondary source of your data. So it's a very conditionally practiced. Terms and conditions are heavily applied. So these are the key material and key component that you should consider before taking any cloud service provider service. You must understand what they offer, what are the terms and conditions, and how they operate. These are the very generic auditing, monitoring, and risk management phase, like what are the the audit process, how you regularly do it, what are the incident, post-incident, and disaster period, post-period, what you do, what are the measures. So these has to be clearly defined. Typically, a very good organizations maintains it, and ITSM audit and a few other things are typically being rigorously being managed. But the same thing can be done on a cloud infrastructure. There is no different in that. So we can go for the cloud if we minimize the lack of trust, we can minimize the loss of control, and we can minimize the multi-tenancy. So there are 3 key points. If you can minimize these 3, the mindset of hosting your services on the cloud, you probably can think about or consider these 3 points. The lesser, the trust level is improved. I mean, the lesser amount of, considering like, I'm putting somewhere my data which doesn't have any certified compliance or any good practice being followed. So you don't trust them, but trust them. We have a very standardized practice. We have certified that data center who we regularly conducts internal audit, everything. So you have your own higher level of trust. So how you can gain your more control over your equipment or your cloud services? You can ask, even there are many cloud operators, providers nowadays who offer to build your own private cloud inside the public cloud. So you can minimize that and have your better control. The multi-tenancy can also be reduced if you go for your own private cloud. So I think my time is is roughly over. There are only one chapter, use case chapter is left. I just in take 1 minute. I'm not going into detail in this chapter. This is a use case. I'll share this slide presentation to the moderator. He will share it whoever is showing your interest to have this data in this presentation. I like to just to add compliment to this. This example shows how you are securing your data, like you are storing or having your sensitive amount of data content on the cloud. So there is a very typical practice globally being used. It's a use case over here. I mean, like you're putting your data, you're using open source technique, you're doing your critical services, you're having firewall. There are so many things, but you're still afraid that your data could be, at threat. So you can apply the encryption. Encryption is like it's a PKI encryption, public key infrastructure encryption. Many cloud provider offer this public key infrastructure based encryption technique. Not only this on a cloud provider, you can also get the similar services from many third-party providers. So you can avail this opportunity and encrypt your data. Even there are chances that your cloud storage data could be compromised, could be leaked, could be shared. But no matter if you have your private key with you, there is no chance of having any untrusted factor working. So it's a typical use case. How are you going to do it? It's not a generic or very symmetric key exchange. It's a purely asymmetric key exchange. That means you are having your private key in your own control. You actually have it with you. So it's a use case example. It has been denoted over here. And there are common services like the Microsoft Office signing, PDF document, email, code signing, VPN services, Microsoft Exchange or any other mail service, web service, two-factor authentications, desktop login. These are all highly secured, and there are many PKI integration done on all these business practice solutions that we use everyday basis. And the fear versus reality, there are 6 advantages. It has been covered by AWS. It is like there is no capital expenditure. There is no, it is of course the massive economics of scale is there. Capacity, you don't need to guess. You just start deploying it. Speed and agility is over there, and stop spending money on equipments rather than developing or building any data center. And you can go global in minutes. So these are the key 6 advantages and benefits. What AWS is actually preaching globally for the last 2 decades. And this is the phenomena. We fear that we don't want to go to cloud, but this is the global standard. In way back 2016, there were globally 849 exabytes of data. And in 2021, it has become 1.7 zettabytes of data. Traffic, I mean, not in terms of storage content, it's the traffic. For its traditional phase. And even the cloud phase started with 6 zettabytes in way back 2016, and now it has become 18.9 zettabytes in 2021. So it's a clear difference between a typical service end and the cloud service end. It is moving, and it is actually, this is numbers, and these numbers have been disclosed by Cisco Global Index, which is called the CGI. So they have actually published it. You can find it. If you can Google it, you can find it. And there's another index, the similar something like that, that 95% of the workload, it was published in way back 2019. So they predicted that 95% of the workload will be cloud-based by 2021, which recently been updated, like it has already been 95%. So they predicted to be 94%, and now it is actually 95%. Probably COVID reason, probably non-COVID reason. There are many other contexts, but it has significantly been grown. And the CAGR, annual CAGR, the compound annual growth rate is 22%, which is very excellent. And the typical service load are declining 5% per annum. And it is the same thing. I won't repeat it again, that it will leverage an entire IT infrastructure, IT resource whatever the convenient places, any provider can actually look after and look forward to deliver these key elements of services. Thank you.
Thank you very much.
I'll go back to Hasan bhai. Thank you.
Yeah, thank you very much, bhai. So can you see your faces? So I would, before going to the question and answer section, I would like to request all the members to turn on their videos so we can have a snaps before this questionnaire. So it will also get make us relax. So so I'll request everyone to please, if possible, then please put on into your cameras, but and give Hasan Emdad bhai a very thank you for his very informative and good presentation. I hope so everyone will enjoy it. Everyone already enjoyed it, I think. So thank you, Hasan bhai. Before going to the questionnaire round, I also like to inform everyone that those who has put a question on the chat box will be get prioritized, and later if you want to ask question, we will please use this raise hand and then ask the question to. So I got the one question from the chat box with by Mr. Partho Pratim, that what are the challenges to update for a hybrid cloud? So as I understand that, what is the advantage of hybrid cloud and the possibility of the risk transfer? So can you answer this, Hasan Emdad bhai? So I think you are in. You need to unmute yourself.
Apologies, sorry. So it's a good question. Private clouds is typically, as I already told you that in the first place, that many on-premise enterprise nowadays are upgrading their ecosystems and have their kind of own virtualized and private cloud. So yes, the hybrid cloud is nothing integrating the private cloud, bridging. It's a bridging between the private cloud, the on-premise cloud, and the public cloud, for instance, like AWS or any other public cloud provider. Yes, it's absolutely possible, and it is the very good practices, and most of the enterprise nowadays keep it as a very common practice, because they keep their major service, considering since we have invested on a private cloud, they keep their major services on-premise, and for certain services like the disaster recovery phase, like the DR or the backup, or even capacity handling process, they move into the public cloud. And public cloud and private cloud, there are software techniques and tools available. It is not a big, big rocket science or any expensive tool. Even there are many open source technique and technologies are available to integrate this public and private cloud. The bridging or the harmonized service, it's quite possible, and it is as good, and it's very secure. So many organizations around the world have this practice for the last couple of years, even those who are very sensitive and keen about their own data. Right. There is another question I also see on the chat box from Mr. Partho Pratim. He's saying that, is there any advantage to reduce third-party vendors? Because now I can transfer risk and responsibility to vendors. Is there some advantages in cloud? In my presentations, I have mentioned many times that on-premise vendor, there are many, you are handling actually many kind of vendors, like the hardware vendor, like the network vendor, like the system integrator vendor, like the software vendor, like the service vendor. So there are 5 or 6 type of vendor that you are actually handling at this moment. If you move into cloud, you probably can eliminate the hardware vendor. You can eliminate the system integrator vendor. You can eliminate the network vendor. So you can minimize your vendor number of vendor list. But at the end of the day, probably you need certain vendors to be on board. For instance, the software vendor, or particularly the service provider vendor. Maybe you need to rely on them on some certain case basis. Other than that, if you're good enough, if your IT resource is excellent, probably you can also do or take away those two services of your own. If it's an in-house developed product, probably you don't need any service. Thank you. There is another question.
Anyone who want to ask a question to Hasan Imdad bhai about this cloud technologies?
Yeah, there is a question from Mr. Shakil.
Yes. So you can unmute and then ask a question.
Mr. Shakil, please unmute and ask your question, please.
I think
okay, if there is no such, so we will. I think
anyone else? Anyone else have any questions?
Anyone who want to say something or anything?
Or if you have any questions on the later part, you can always reach out to our speaker. He has given his email address in the presentation slide.
Before, yes, thank you, Jackie. Before concluding, I just want, Mr. Abu Haidar Muhammad. Yes, please.
Please unmute. Please unmute.
Yeah, please unmute yourself.
Assalamu alaikum.
Walaikum assalam.
If an organization like to adopt a cloud storage and or SaaS platform, is there any need to keep a DevOps team for the organization?
It depends on the size and scale of application and service. It depends, but typically you don't.
Yeah. Okay. Thank you very much.
So
another question in the chat box. Zaki, he said that it is a good practice to look for relevant certification to the DC service provider whenever opting any cloud model during a project or for my business. Yes, it's a good practice. I mean, if the data center has already been certified, there are many certification models. As I said, that for financial modeling, there is PCI DSS certification data center. For health related, it's an HIPAA, HIPAA, AAA, and there is for service related, there are TIA or Uptime Institute certification. So it gives a certain amount of tiering architecture certification, like what tier of data center is all about. And there are plenty other like ITSM services, or there is ITS services in ISO certification. So there are many certifications are available. So if any, typically a good quality data center, apart from, let's assume, from those global player, global players may have many different certifications already done. But apart from that, there are many semi-intermediary or local data center who are delivering cloud services. So they may have certain amounts of certifications or compliance already being done. So it is a good practice to select somebody who already has done something, some certifications, or has done a compliance.
So we are running a little bit of late.
Right.
I think also today is one of the Jumatul Bida in a very important Ramadan. So I think with that note, we want to conclude this session. And we all will request our members to. I had received one question permanently that after being a event, what is the purpose of this code for this PDU code? So you can basically use this PDU code for 2 months from the event happens. So those who are actually concerned about that they didn't able to use in between this or in a month. So please note that it is we have a policy that we basically give 2 months for a period to allow your PDU code to be charged in this PMU or PMI CRS. So and any other information you want to do and you want to make some comments or any kind of information suggestion, you are always feel free to communicate with me directly if you like, or you can have some mail directly to me. I have provided into the chat box. Also can connect me directly. So with the note, today I think we are concluding this session. Thank you very much for joining, and we will be coming month. We will be provide another 2-3 sessions. We'll try. In the Ramadan, we have taken a break. I think you have seen that this is the first we have arranged in the Ramadan, but in coming month we will arrange another 2. So please stay with us. Thank you very much. Welcome. Allah Hafiz.
Thank you, everybody, for the session. Allah Hafiz.
Thank you.